Today we are going to look at the topic called chi-square, and we are going to do it in Excel. And it's coming from the book called Statistic for Managers using Microsoft Excel, 7th edition. Wonderful book it is, and unique way of explaining the statistic and very simplified version you will find it. And particularly in the past videos also we talked about the chi-square using Excel, but this video is going to be very special because we are going to learn another technique, another method of calculating the chi-square. Although this method is long, but strongly recommended because we can understand what is something called critical value, region of rejection. When you will, at what point you will say the values are being, we have to reject, right? So this is something called x square we're going to learn. And what is the difference between critical value and the region of rejection, that is x square, we are going to learn. So we all know we are anything of this one is we call it as the confidence interval 0.95, that is 95% confidence, and the level of significance we are going to keep it like 0.05. That means that will give us the confidence level of 95%. And this is the very unique method, and usually we don't explore that one, that x square. This is what I'm talking about, region of rejection. And the summation of, you just have the total summation of everything, and if not, that is the expected frequency or expected value minus the sorry, this is observed value, sorry, go for observed value. Let me just elaborate here. So this is observed value minus expected value or frequency, you can call it, whole the power 2 by, we are going to again divide by expected value, or another word, frequency, right? So this is exactly where what we are going to learn it. If they, what is our idea is that a very simplified way, that's what I'm just I love this book. The expected frequency is particular cell if the null hypothesis is true, right? If we have that, we can also going to learn so this value also as well. Okay, another thing is that how to calculate that proportion method. Now, this book is recommending to use a proportion method so that we can easily calculate it. So even in the stat guide, we cannot calculate the chi-square because we have to work around, we have to find out that expected value. That expected value we're going to learn from the p bar, that is proportion. For example, the sum of rows divided by and the total values, right? And similarly, we are going to do it. So I will explain what is p bar for each region, that I'm going to explain. So let's start. There are two examples we are going to do. The example number one. So this is coming from this book, page number 433, 31, and all that you will find it. And particularly, this is the situation. And you have a hotel, like beach Kumbar is a hotel, and windsurfer is another area where the hotel is being placed. Now we wanted to know. So these many people have, for 163 people have vouch for yes and 64 for no and all that. So we wanted to find out whether they are significant difference between these two proportionate, right? So, and then this is the method we are going to learn, the proportion method we are going to learn. And eventually we're going to learn all that values, how to find out the critical value and chi-square test statistic and p values and all that. And also we're going to compare with the normal method also as well. So this is the value is given. This is a given value. So in the given value, what you have is that choose hotel again. So beach cumber and winds surfer, right? So these two, one, right? Whether the customer will choose this hotel again, and we have a value 163, 154, and all that. From there, what we need to find out is we need to find out the sum value. So sum of this, so between these two, you got this. And then similarly you can find the same thing here, right? 172. So you can find it here. And then you will also be by column, you will, now we have done with the row, and by column also we will say find out, right, sum of these two, 227. And then, so now it is like prerequisite, we have completed this one. This is the given value, so yes and no. only discrete we have. This is also called non-parametric test. So, and from there we wanted to find out the region. Level of significance is 0.05, and degree of freedom. Degree of freedom is very unique way this has been explained in this particular book, right? So it is number of rows minus one, number of columns minus one, right? Sorry, this is minus. Let me re-edit this. Minus one, right? So what is mean by that? For example, number of column, how much we have? Two columns we have, right? Two minus one. Maybe I'll put it up here. So number of column we have two, right? And minus one. And similarly, number of rows. So how much discrete we have? Two, right? Again, I'm going to write two minus one. So degree of freedom is of course one, right? So this is the easy way we can, because this is from this we are going to calculate. So this is the method one. In the past videos also, in the we have discussed this one, and the in this method what we are going to do is, I'll quickly go through this value. So in the method one, what we learn is that, so from you can have only the sum value. For example, in this case, I have just inherited 227, 262, 489, and things like this. And the method one is quite uh, easy. So I mean 227, the end of column times end of row divided by the total value, right? The total value I'm going to apply, sorry, total value I'm going to apply for everything. So I will give a dollar symbol, because just to denote that is the absolute reference. So 147, that means for the 163, the expected value is 147. So let me keep it one digit, two digit, sorry, two decimal place. I'll copy, I'll paste it here. And now what I have to do is, I have to slightly, denominator I don't need to adjust, only the numerator I have to adjust. So how I'm going to do is that I'm going to again end of column times end of rows, right? End of rows we have, let me do it again. Let me do it again. So 262 divided by the end of one. This is done, right? And then similarly, what I will do, I have to do it this one. So again, once again, I will just take it end of column times end of row. All right. Similarly, we can just find it here. And one more time, I can just do it here. End of column times end of row. So this is done. This is expected value. This is in the old method. Like we can easily find out by remembering that end of column and times end of row divided by total value. This is one method. Let me repeat again. End of column times end of row divided by total value. We can easily find it. This is one way. Another way, what I learned from this book today is that there is something called proportion method. So this is the method we are going to learn now. So what this method will do, so simple, we can just add, for example, we have this sum values. Yes, right? The sum, total sum, yes, we have, divided by total value. This is proportion. That means 64 percentage. We can say that it is the people are choosing that hotel, right? Altogether, right? And then similarly, we can do 172. There are two methods. Like one minus this one is going to be minus the s is going to be no, but we can also do this divided by this. We can do this way, or we can one minus this way also is gonna be, both are pretty much same, right? So now we got the proportion, right? P for proportion, we got the 64 percentage is yes and the 35 percentage is no, right? The same value, I'll keep it in percentage so that you can get it. Okay, so now you can see here. So I've got that 35, 65 percentage is yes, and now we are talking about overall, but we have to differentiate by these two hotels, right? So how we can do? Again, it is going to be very simple now. So what we can do is that, so we can multiply this 64 times, and 227 is a total value. You can take it from here, and both are same, right? So you can take it, and similarly you can copy, paste it here, and I'm just checking that, so it is taking from the same value. That's okay, both are same value, right? And you can see that in this 147, the method one also same, method two also same. Similarly, like you can see this value times, and then 35%. So both are matching it, right? I'll keep it only two decimal. Here also I'll keep it two decimal so that we can easily compare. Yeah. So the last and final one is that, again, once again, this value, or in any of the values we can take it, times this one. So that means 92. Both are method one, same expected value we got. Method two also we got the same expected value, right? And now you can see 163 is the actual observed value, but the expected value is 147. Like this, we got it. Now, this is a unique way that x square, right? We talked about this particular region we are trying to find out. At what region of rejection, at what point we will reject it. So now in this case, this is the formula. Let me do it. 1 equal to, so the formula is, I will just maximize that formula so that you can follow it. Yeah, I'll keep it here. This is the formula. So submissive of, so because we are talking about total, it's called submissive, right? Total, we're dealing with the total only, right? At the end, we will total it. And first, we will find out this two. Observed value minus expected value. So observed value minus expected value, right? Whole the power 2 divided by expected value, again 147. So 1.71, right? So this is, one second, I have just, sorry, I have to put it up here. So sorry. The formula is, we are trying to find out x square stat. So 1 observed value minus expected value, and whole the power 2 divided by, and then observed value. Sorry, expected value. So we got the same thing, 1.7 and all that, right? So similarly, the same thing you can horizontally deploy, right? So the same region, you can see here 1.7 is matching, and 1.47, and then 3.1 and 2.7, this matching. So once it is done, so we can easily calculate the rest of the things. So critical value is nothing but chi-square invert RT. That means you're going to give probability and degree of freedom. Probability is 0.05 and degree of freedom is 1, right? So we have already calculated. And then the chi-square test for statistics. So this is the entire value, right? This is called region of rejection, right? So entire value, if you sum this is called region of rejection. And then the last and final one is that in this method we're going to see like chi-square distribution RT, right? Root we are going to find, and what we can add the value is that, maybe I'll do it this one. Okay, probability is 0.05, comma, degree. Okay, maybe I'll just add it here. So here you can see D23. D23 you can see here. This is the statistic value we got it. That is X value. And D9. D9 is our degree of freedom. So this is what value we got it. And now in the simply we can also add it like chi-square. And then so you can here actual value and observed value are same. You can see comma and expected value, right? Can give okay, and you got the same value. So either this long method we can do, or you can quickly do using the observed and expected. You can directly go around that, right? We can easily find it out, but both method are okay. But this method is giving more clarity that what is the critical value we got, what is the critical value we got, what is the rejection, everything. We are getting more and more information from this, right? But both are same. And then I'm just giving one more condition, like if our condition d12 less than 5, and all the cases less than 5, I'm just keeping that target, and whether it's meeting or not meeting, so expected value is met, right? That's the condition I'm giving it. So similarly, the same example, you can see here example number 2. In example number 2 is that here we have 2 rows and 2 columns, but here we have and three columns we have, like Golden Palm is one, and Palm Royal and Palm Princess, and then only we have 2 rows, like yes and no. Discrete is only 2, right? Again, once again, we are going to do the same thing, but this will be very quick. So what I'm going to do, this is method 1, very conventional method. What we can find out is that we can just do this value. What I will do, I will just do for only one so that you can get it. So in this method, so end of column times end of rows divided by whole value. That whole value, I'm going to keep it like dollar symbol so that I can apply horizontally. You can see here, this is all done, right? So similarly, you can do it here. If you wanted to do it another method, that is, this book prescribed this method in order to get more and more information. So how we can do? So first, you can just add that sum of A's 513 by total, right? So we can get to know that the choosing hotel is 73%, right? And then the other one, sorry, 187 by 700. Another word, we can also do 1 minus this value is also going to be same. You can check here, is also going to be same. Both any one of the methods you can do it. Okay, so this is all done. Once it is done, we are going to find out the expected value. So in this case, expected value, now it is super easy. So you don't need to do a division method and all that. This is super easy. How we can do? So times this, because we are dealing with S times, and what is the value, the total value, right? So 187. We can easily deal that value as such, right? Similarly, you can find here. Similarly, you can find here, right? And similarly for no, you can find here, and then similarly you can find this. Similarly, you can find this, right? And then let's calculate the critical value. Critical value, we already know. We need the level of significance and degree of freedom. And chi-square test for stat, that is R square value. This is our the x square value. So you basically sum all of that, right? So if you sum all of that is 40, right? 40.22. Exactly, it is matching in this book also as well. You can see here 45.99 is matching and 40.22 is matching. And then lastly, we can just see that the chi-square test we have done using both the degree of freedom and then the chi-square test value, and we got 0. Even in the normal method which we do, right, chi-square test, simple method, and you are going to take the the observed value and then expected value. So just give this, and is also going to be, because it's very very small and in 0, so you can easily compare that value also as well. Even if you put into general, and you will find the same value as it. So I've already compared these two value, and you're getting it 0. So finally, what you can do, you can test this assumption. If these are if this value, that is D11, that is expected, each individually expected value you're checking now, each expected value, you can double click on this. So you can just see if this less than 5, right? Because our 5% we are talking about, right? So that it is violated or met. So it shows like wait. That means in both the case, example number 1, that means this is significant. So expected value, whatever the expected values we are getting it is significant, because we have to reject the null hypothesis. We have to accept the alternate hypothesis because it is less than uh, this value, right? And exactly in the same thing here also the same. We have to reject the null hypothesis, accept the alternate hypothesis. The fact is P remains zero. Perfect, right? So I hope you find it very useful. And if you need this Excel, you all you have to do is you have to just comment it, and I will share this Excel also as well. So that all you have to do is you have to just keep the value and automatically everything will calculate it. For example, let's say I'm just keeping here. I'm just creating this as a 3. 3 was already there. I will keep it like, yeah. Okay. So now if you look at here, if I give the value, let's say the golden palm has been selected 150, and this is 130, this is 120. Let's say no, let's say 30, and then you have, okay, let's say you have 20 and here you have 12. I'm just giving an example. So one thing what we have not done is that we have just not applied the formula. Let me do it here. Copy, paste, paste this, paste this. We are going to apply sum this up 400, and this should be correct, right? So totally 462, and then you can apply the same thing here. This is the value. You can see here rest of all the other things got automatically calculated. All you have to do is that you have to just give this value, automatically all these will get calculated. Even in this assumption also, now this assumption, now it is not true. I mean the value is actually both are in both method is absolutely correct, but in this method it is we have to accept the null hypothesis. There is no difference between yes or no, right? There is no statistical difference because it is greater than 0.05. There is 15%, right? It is greater than level of significance. I hope you find it useful. Please do share, like, share, subscribe my channel. You have wonderful day ahead.